Welcome to Depth Camera Central Volume 35. This is my first dedicated eye tracking video, and we're going to review using neural networks like you see here on the OPENCV from DepthAI Luxonis OPENCV developer kit, or using near infrared illuminators like the Hololens 2 or the Pico Neo 2 or even the Varyo XR3 VR3 using 200 Hz Tobii eye tracking. Let's dive right in. Hello and good morning. My name is Tony Rogers and welcome to my first dedicated eye tracking basic concept review video. So let's jump into this first. Now, one of the techniques that is mostly used across the entire industry right now is called pupil center corneal reflection, or PCCR. Now, this basic concept uses near infrared light to illuminate the eye, which causes highly visible reflections, and then another camera captures the image of the eye, showing these reflections in real time. Now, that image is captured by that camera and then is used to identify the reflection of the light source on the cornea. We call that glint inferencing, and in the pupil. And then we can calculate a vector via a formed angle between the cornea and the pupil reflections. And the direction of this vector, when combined with other geometrical features of the reflection, is then used to calculate the gaze direction. That's very important to understand. So utilizing near infrared illumination at 200 Hertz, which is what Varyo is doing, is then used to create reflection patterns on the cornea and the pupil of the eye, and then we have image sensors are used to capture images of the eye and those reflection patterns. Now, advanced artificial intelligence, machine learning, AI inference models are then used to process via different types of algorithms and to create a physiological 3D model of the entire eye. And those are used to estimate the position of the eye in space and the point of gaze with incredibly high accuracy. Now, all different types of systems moving forward will have eye trackers for a very powerful reason, and as I alluded to in a previous video, it is because mostly of foveated rendering to reduce the GPU computational load, to increase frame rates and reduce latency. All of these things are important, and mostly to reduce the size or the energy density of the battery that would be required on other untethered headsets that you will see in the market. Qualcomm will mostly drive these new types of integrators across the entire spectrum, okay? But as we jump into the foveated rendering of this as eye tracking, I want you to really understand all of the different metrics that are being tracked in these new virtual reality HMDs. So you'll 200 Hertz near infrared eye tracking. You'll have hand tracking via LiDAR sensors on the front, or even AI inference models, machine learning models like the Oculus Quest 2. And you have other biofeedback systems that will be used to augment and improve users' interactions inside of these ultra photorealistic environments. So it's really amazing to think about and to postulate in your imagination how these things will be implemented and used in the future, and how these advanced image processing algorithms will create highly accurate 4D labeled data sets in real time of your eye and all of your biometrics, okay? So let's jump into foveated rendering of this, where I will show you using your eye and then how it reduces the computational load on the GPU and obviously on the battery system as a whole. Thank you so much. Let's jump in. Hello and welcome back. Now follow along with me really quick and place your thumb out in front of you. This small quarter-sized area represents your fovea, which represents approximately 1% of the human perception engine, which means that 99% of the human perception engine, our vision, is filled in. It's peripheral. It's low resolution. I always find this ironic because humans rationalize that we see so much at any one period in time, when in reality we don't see very much at all. Our brain fills everything in. If our computational system, our prefrontal cortex, was required to render our entire field of view in high resolution, it would be approximately 10 times bigger. But the irony is, virtual reality devices are doing this right now. They're rendering the entire scene at the highest frames per second, which is what is causing such a slowdown in GPU efficiency, but also why we need bigger batteries on untethered devices. So moving forward, integrating eye tracking devices at 200 Hertz provides a pipeline, a streamlined platform where we have access via infrared glint inferencing from your retina. We know exactly where you're looking at any one period in time, okay? And from there, we only need to render this one area. The rest of the peripheral can be low resolution, which is what the Varyo XR3 and VR3 are doing. There's a low resolution screen behind in the background, and then there's a high resolution screen that follows your eye tracking and renders in ultra high resolution. And there's some other implementations via ZeroLight. They're using variable rate shading to kind of streamline this and put everything into buffers for pixel densities, which is again reducing the computational load on GPUs. In the past, they were rendering 2 different renders for the peripheral and then the high resolution, which caused an excessive I would say loading on the CPU. And now moving forward, they're seeing via these new NVIDIA GPU systems, you can essentially integrate these variable rate shading systems to decrease the latency and increase the frame rates exponentially. I'll throw a video up here that kind of showcase that via this scene here that you can see that versus 60-70% on the normal virtual reality device right now that renders all at one time versus only rendering the center area. Now obviously there's some other implementations that ZeroLight has also done with Volvo and Volkswagen for eye tracking simulations in marketing videos and sales and service. So imagine you're going in to look at a vehicle, and I'll throw that video up right here, where you want to see where the users, where the customers are looking. And what that represents is what they value. Some customers value rims, some customers value the material and the leather and the aesthetics of interior and the engine. And all of these things in customer-based feedback will be provided via eye tracking initiatives. But there's also something else I want to reference here that was touched on by Facebook and various other social media companies, is when advertisers are showing you videos, they want to see how you feel. Now, eye tracking systems, again, that are using near-infrared illuminators can provide emotive feedback when coupled with AI inferencing models via a neural net. Okay, and that's powerful. What that's doing now is they could show you 10 example videos that would say, okay, out of 7 out of the 10, he liked these 7 out of 10, but really they only liked 2, and they were looking at these areas of the video where the person was showing a product or they were out in the public in some kind of an environment. It provides unbelievable contextual feedback to engineers and developers, but to the company. They understand where they can focus their initiative in advertising and marketing, and obviously that increases the return on investment for every single corporate entity or manufacturer or company in the world. It is incredible to think about. So I wanted to show this to you because right now you don't really feel these emerging technologies in any of your products, but they're already being integrated into cell phones via the front-facing infrared flood emitters on the new iPhone, 60,000 points. They can see where your eyes are moving when you're looking at advertisements, when you're consuming content online. But in the future, as everybody moves to near-eye displays and HMDs, in the next 18 months, these types of systems will help alleviate excessive costs in the system, because we want to drive down all the additional components that would be needed, but also we want to slim down the energy density of the battery. We want to remove any additional optics or component systems that we don't need, that that cause certain type of ergonomic issues. But again, cost is a major driver when we think about adoption rates across the entire industry. And that's, to me, a functional aspect that we need to really focus on moving forward. But I just want to show you guys this, so I'm going to focus in the middle. Now imagine that I was in a game, and this middle area is where I'm interacting, I'm moving, maybe there's a missile coming toward me, I have a sword or something. But if I were to look up there, now it would only render in that small circle, in that fovea area, that small 1%, and here, and here, and here, and here, as I move down and up and over and in the middle. But let's also come back to social interactions and education in colleges and universities and marketing videos and connection, like Zoom. I've spoken at great lengths about this as well. This is where I feel like there's a gap in interaction in the ability to connect with people. And when you log into these systems now, again, using infrared trackers, but also AI inferencing models, you'll be able to see someone's face as they smile at you. You'll actually feel that connection, which I think is significantly missing across the entire spectrum of emerging technologies, but more specifically in virtual reality HMDs and spatial computers, and especially education like Zoom for children and in college. So when you put this headset on and your professor's standing in front of you and they ask you a question and you can feel their gaze, now with hand tracking, with face tracking, emotive tracking, with voice analytics and biofeedback mechanisms, via haptic systems, you would be able to feel a much closer connection to the educators. And again, this talks, this kind of comes back to my previous discussions around the transformation in the education community across the world. And I think eye tracking may play one of the biggest parts within all of those components. It's fascinating to think about. But thank you guys so much for tuning into this brief introduction into eye tracking technologies and foveated rendering. Again, I think as these things come together and as computational systems like the Qualcomm XR3 and beyond come in to the fray, I truly believe that it's going to transform and be disruptive and innovative overnight. It's going to happen so quick we won't even have a chance to blink. Thank you guys so much and have a wonderful weekend.